Hi, this is an introduction to how to complete your Lab 4 Part 2, and I am going to go over that with you. Let me just turn off this text thing that just popped up. I don't really care about it at all. All right, so basically, you're going to be watching a video of a Prius coming to a stop on ice. So it starts out at not a Prius, a person. He starts off with a speed, running, and then he slides to a stop on an ice. So the only force that's acting on him is the friction force. And remember that friction is equal to mu times the weight in this case because he's standing on a horizontal surface. So the normal force that's acting up on him is equal and opposite to the weight pulling down on him. So friction is equal to mu times the normal force, and in this case, that would be mu times the weight. And remember that weight is mg. So in this lab, you're going to be finding the coefficient of friction. You have a couple of ways that you could do it. You could make a graph. You could make a graph of to determine the acceleration of this object, right? And if you notice, if you plug in mg into this formula, mu times mg equals ma, the m will cancel out, so you don't even need to know m. So you could make a graph to find the acceleration. You could do that using, you could measure the distance every instant in time and get a parabola, do a quadratic fit, and take half of the coefficient a. Would be half of the acceleration, double that, and that would be the acceleration, just like we've done in other labs. Or you could actually just use the video to get the information to solve a kinemax equation. So a kinemax equation that would be helpful here, if I wanted to figure out the acceleration, I don't know the initial speed, but I can measure how far he skids. Right? So I can actually use the measure tool and figure out his skid mark distance, and from the video I can figure out how long it takes to skid, and I know that that I could use the formula x equals 1/2 at squared plus vit, where vi is 0 to start with, and that would simplify down to the change in, his skid mark equals 1/2 of his acceleration times time squared. So I could figure out his skid mark and how long it takes him to skid, and I could find acceleration that way. So I can do it two different ways. I can make a graph of position versus time and do the quadratic fit to find x equals 1/2 at squared plus vit, and use the coefficient a in that expression, which will be half of the acceleration. Or I could just measure the distance that he skids, and I could then figure out how much time from the video it takes to go that distance, and just use the quadratic function anyway. Delta x equals 1/2 at squared. It probably would be more realistic to use the graph because you'd be using a real function that models the data. But you can probably get away with using the kinemax formula. Once you know what A is, then all you have to do is plug into this formula and solve for mu, right? Because this would be mu equals weight, which is mg, equals ma. So mu times mg equals ma. And the m's cancel out. And you know what g is. It's 9.8 meters per second squared. And you would have calculated a. And then you just solve for mu. So it's pretty simple. And it's just a simple exercise in doing a real-time calculation.